Okay, so we're going to call this section 5, I'm sorry, we're going to call this section 7.7 when you see the assignments there. And this is going to then do the first part of two sections, which is 7.7, then 7.8, that deals with non-right triangles. So this is the first section that we're going to sort of address that. And the first one is called law of sines. Okay, so there's a law that says, or a proven fact that says, in a non-right triangle, it works in a right triangle too, but used for non-right triangles, there's a relationship between these ratios, sine of big A over little a. Now, what does that mean? That means I have this angle and the opposite side. That's how big A and little a are related. That is equal to a relationship between sine of angle big B and little b. So again, that would be then here and the opposite there. That's also equal to this one, sine of c over little c. Hard to make a big C and a little c, but same thing here. That's the relationship. Now, we write three of them. We will never use three of them. We only use two of them. And the idea here is, I'm not a huge fan of this thing here, okay? But it does emphasize that they're all equal to each other. But then what we're going to talk about is it's the sine of the angle over the opposite side equals the sine of another angle over the other side. Now, what we're going to find out is this works for certain triangles. Now, the examples we're going to do today work. One of the most common ones where this will not work, if you can picture it, is if I give you a non-right triangle and just give you the three sides. How do you find an angle? And then we're going to do that next section, something called law of cosines. Now, this one will work because I have an angle on the opposite side. So what am I going to write here? I'm going to write sine of 35 over, can you tell me which one? It's going to be over 12. And then that's going to equal sine of 71 over x. Okay? So again, I'd like you almost not to focus on the A's, B's, and C's, though they do help sometimes when you lay it out. But in this case, if I know an angle on the opposite side or it's marked, I can use law of sines. And then what do I do? I cross multiply. Now, if you're doing the Herneisen shortcut here, the cross you know, divided by the cross you don't. If you can put that in your calculator, make sure you're in degrees, you're going to get x equals 19.8. Now, let's do a quick sanity check. Does that make sense? I think so, because this x is opposite 71. So it clearly has to be bigger than the one opposite 35, which is 12. So it doesn't give you an exact answer, but tells you at least if you're plus or minus the right way. All right, let's look at number 2. Number 2 also works, right? So we set up the same thing again. I know an angle, sine of 18, and the opposite side. I'm good to go. And then I know another angle, so sine of 114 over x. And then what you would do again, do your cross. So the cross I know, divided by cross I don't know. You can put that in your calculator. You would get an answer of 14.8. If we do the quick sanity check here, does that make sense? Yeah, 14.8. Yeah, obviously a lot longer than 5, 114 versus 18. Okay? So that's the general gist of it, if we have it. Okay? Now, if we head down here, now, what happens if I want to find an angle and it's set up this way? All right? So if this is set up for that, let's use what we learned in section 7.5 on how we would do an angle. So this one takes the extra step. So what's going to happen here is I do have an angle in the opposite side. So what I'm going to do here is I'm going to write that first. So sine of 77 over 14. I guess I shouldn't say first because it doesn't really matter, but I'm going to set up the one I know. And then what do I have? I have sine of x over 9. Now, the way this is going to set up is we're going to do our cross, and our cross is going to give us an answer for sine of x. And then if you remember from the last section, I have to take the sine inverse of that to get the answer. So if I do the cross I know divided by the cross I don't, notice this is sine x, not just x. So I'm going to get sine of x equals, and I encourage you to put this in your calculator and make sure you get it, 0.6264, so I'll just keep a bunch of decimal places. Now, from the last section, how do you find an angle? The way you find an angle is you take the sine inverse, or you take the trig inverse function of it. So if I take the sine inverse then of 0.26264, and again, I'm writing this time. You wouldn't have to write this for me if you know the process. This is going to pop out an angle for me about 38.8 degrees. So just to emphasize there too, we do accept decimal degrees. So if they exist, we encourage you to use them. And does it kind of make sense? Just a quick check. 77 is opposite 14. Yeah, it makes sense. About 40 is opposite 9. So at least they're in the right frame. All right, let's try number 10. I'm going to set up the cross I know. So I'm going to set up here sine of 126 over 31. Okay, and that's going to equal sine of x, because that's what I'm solving for, over 15. So again, to emphasize the process here, all right, what we're going to do is do the cross we know divided by the cross we don't know. It's going to give you a decimal, by the way. It'll always be less than 1. If you did it correctly, set it up correctly. So what I'm going to get here is I'm going to get sine of x is equal to 0.3915. 4 decimal places keeps me pretty accurate. So how do you find then that angle? Again, I'm going to write this so you wouldn't have to, but I'm taking sine inverse of 0.3915. That undoes it to find x. And that would give me then, yeah, they just list that as 23 degrees. I don't know if that's exact or not, but if it is, we'll take it. Okay, so that's how we use law of sines then to find an angle, given an angle on two sides. All right, now the relationship again has to exist where you have an angle and the opposite side, right? So you have an angle and the opposite side. If you don't have that, we're going to have to go to the next part, which is going to be something called law of cosines. But that's the video lesson for today. When you come to class tomorrow, we will review these. Thanks for listening.